Good morning, students. This is Dr. Eustace Russell, working as Assistant Professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are seeing the subject called Robot Dynamics and Control, subject code RA3601, under the regulation of 2021 for the 6th semester for the 3rd year students. Last class, we have started with control manipulators, and we have seen closed loop system, open loop system with various examples, and some of the expression also we have covered in the last previous video. Today we are going to see the remaining topics in that. That is non-linear control of manipulators and Frobenius theorem. Non-linear system, state space, representation, single input systems, Frobenius theorem, live brackets, controllability, and application in robot manipulators. These are the topics will be covered in this video. Now, what is nonlinear system? That is introduction to nonlinear system. We are going to see what is the meaning of that. Nonlinear system is one in which the output is not directly proportional to the input and the principle of superposition does not hold. So here one thing we have to easily understand that output is not directly proportional to the input. That is important. Not directly proportional. This is non-linear. So what is the expression m of q? Q double dot. Q double dot means differentiation in with respect to time in twice. That is double dot is quotes is given. And C q dot and plus g of q equal to tau. Tau is nothing but joint torque. M of q is inertia matrix. Then C is Colles and centrifugal forces. G of q is gravity vector and tau is the joint torque. Sources of non-linearity: friction, gravity, joint coupling, gear, backlash, flexible links. Then general form we can define like this, that is state space representation of non-linear systems. In that general form is given by x dot equal to f of x comma u. X is nothing but state vector, u is nothing but control input, f of x comma u equal to non-linear function. Various advantages it is given: suitable for MIMO systems, easy stability analysis, used in modern control design. Example is also given for your understanding. X dot x1 dot equal to x2. The same thing will be written like that: x2 dot equal to minus sine x1 plus u. Now general form we can write like this for the single input non-linear systems. What you can write means x dot equal to f of x plus g of x u. F of x is equal to drift vector field, g of x is equal to input vector field, and u equal to single control input. And example is also given, that is a DC motor driven joint, that is j theta double dot plus b theta dot plus kti. Here we can see the mechanism is represented in the lower side of the right hand side. Motor is there. That connection will be connected coupled with the gear system, and that movement will be transmitted to the robotic arm to get a twisting movement over there. The various application it is mentioned over here: robotic joint control, servo motor systems, mobile robots. So background of this theorem, Frobenius theorem. Why do we need this theorem? Non-linear control system robot motion is often constrained by the available control input. We need to determine whether the allowable motion directions can be combined to form a smooth surface manifold in the state space. Frobenius theorem provides a mathematical condition for determining whether the distribution of vector field is integrable. Key definitions, that is distribution. Distribution is nothing but is a collection of vector field representing all possible direction in which the system can move. So that is a distribution. Therefore, the vector field under what direction or where the robot can move. For a non-linear system, that is x dot equal to f of x plus, that is summation of I to I equal to 1 to m gix ui. The vector field gix define the distribution, that is defined like this: span of g1 g2 upon gm. So this is the length that is mentioned as the span, how much it is moving in all directions. Then integratability, a distribution is said to be integrable if there exists a smooth surface. It belongs to the distribution at every point. Then this theorem, a smooth distribution del is completely integrable if and only if it is involute. Mathematically, for all vector field gi and gi belonging to the distribution. Interpretation, if the lie bracket of any two vector field remain within the same distribution, then the system trajectories lie on the smooth manifold. Then geometrical interpretation of Frobenius theorem. First is the geometric meaning. Consider two motion directions available to a robot. Move along a vector field g1, move along the vector field g2. How to perform this? Motion along g1, motion along g2, reverse motion along g1, reverse motion along g2. So this is the geometric meaning. The two motion direction available to the robot. If it is moving forward, that is g1, g2 along one direction. Again reverse motion along the same g1. Already we specified that there is a span length of that, span distance, that is mentioned as a g1. How much distance is it traveling in a forward motion? How much distance it is traveling in a reverse motion? The resulting displacement is representation by a lie bracket, that is g1 comma g2. The case 1 is given like that. The lie bracket inside distribution is nothing but g1 comma g2 epsilons to the del. The system remains on the same manifold. Result will be distribution is integrable, Frobenius condition satisfied, motion is constrained to a smooth surface. So if it is constrained to the smooth surface, this is the one condition. Case is inside distribution. Inside distribution. For it is under the control manner, it is under the smooth surface only. Lie bracket outside distribution. This is one thing. The new motion direction is generated. Accessibility increases. More states become reachable. Important for controllability. Because this is coming under outside distribution. The previous one is coming under the smooth surface. The new motion direction is generated. For example, if it is new motion, it is not within the limit. The new motion will be generated. So accessibility will be increases in this. So more states become reachable. Then controllability and accessibility. Accessibility is nothing but ability to move from one state to nearby state. For example, one robot is moving from one state to another state, one area to next area. For the industrial assembly side means for one state to another state for this next area. That is controllability, ability to move from any initial state to any desired final state. For example, initially it is in one state. If it is moving from one state to another state, how much distance that is traveling, how the controllability. That is how much it is ability to move. Then relationship with this theorem, with this Frobenius theorem is nothing but lie brackets generate additional directions. These directions determine reachable state, accessible regions, controllable subspaces. So this this lie bracket is generate some additional direction. So how much it is reached, how much is accessible or not, that region is accessible or not. Then controllable space, subspaces also will be given. Here there is a loop is also given for your understanding purpose. Start states, then relevant states, reachable under optimal policy, reachable state, then all state. Reachable state is up to this. Then all states, how it is reach for all possibilities. That is also will be studied here. So these are the various references which are used to prepare this content. Kindly go through these references. That will be very useful for you people. Thank you all for your kind attention. Please subscribe the video. Share this video to your friends. Kindly go through the references what I given in this video. So we will meet in the upcoming video for this same unit, that is control of manipulators. Thank you, students.